Hello everyone, welcome to this video on circuits and networks. In this video, we will study about ABCD parameters. So this ABCD parameters is otherwise known as T parameters or transmission parameters, and it is also known as cascade parameters or chain parameters. It is referred to as T parameters or transmission parameters because they are used for the analysis of power transmission lines, and they are known as cascade parameters or chain parameters because they are useful in the analysis of networks connected in cascade manner, that is connected in series manner. Okay, next is here in the case of ABCD parameters, here we will designate the input port as the sending end and the output port as the receiving end. Here we can see the dependent variables are V1 and I1, and the independent variables are, in this case it is V2 and minus I2. Here minus I2 is used rather than plus I2 because here we are considering the current to be leaving the network, and usually our convention is to consider I2 as positive when current is entering the port. So here we are considering the current I2 to be leaving the network, and this is done for conventional reasons. That is, when you cascade two ports, that is when you connect the output of a two-port network to the input of another two-port network, it is most logical to think this I2, this current, as leaving the two-port. And it is also customary in the power industry to consider I2 as leaving the two-port. And here you can see V1 and I1 are the variables of the input port, and V2 and minus I2 are the variables of the output port. So the two-port parameters provide a measure of how a circuit transmits voltage and current from the source. This can be considered as the source. So how a circuit transmits voltage and current from the source to the load. And they are useful in the analysis of, as I said, they are useful in the analysis of transmission lines such as cables and fibers because they express the sending end variables, that is V1 and I1, in terms of receiving end variables, which is V2 and minus I2. So here the sending end variables are expressed in terms of the receiving end variables, that is V1 and I1 is expressed in terms of V2 and minus I2, and that is why they are called the transmission parameters, and they are used in the design of telephone systems, microwave networks, radars, etc. So now we will see the equation of a two-port network, that is V1 is equal to AV2 minus BI2 and I1 is equal to CV2 minus DI2. So here the dependent variables are V1, I1 and the independent variables are V2 and minus I2. Here it is not B and D is not negative. Actually current I2 is negative. Okay. So we'll see the matrix form of this. So this can be written in matrix form like this, that is V1 I1 is equal to matrix ABCD into V2 minus I2. So in order to find A, B, C and D, first let's set I2 is equal to 0. If we set from this equation, it is clear that if we set I2 is equal to 0, then we will get the parameters A and C. So I2 is equal to 0 means we are open circuiting the output port. So we will get A as V1 divided by V2 with I2 is equal to 0, and we will get C as I1 divided by V2 with I2 is equal to 0. That is clear from the equations itself. And in order to find B and D, we have to set V2 is equal to 0. V2 is equal to 0 means we have to short circuit the output port. So we will get B and D. From this equation it is clear that B will be equal to minus V1 divided by I2 and D will be equal to minus I1 by I2 with V2 is equal to 0. Both with V2 is equal to 0. And now we'll name this A, B, C and D. That is A is the ratio of V1 to V2. That is, it is the ratio of voltage gain, and it is called the reverse voltage gain because it is the ratio of voltage at the input to voltage at the output. So it is called the reverse voltage gain. And since I2 is equal to 0, it is called the open circuit reverse voltage gain. Next is C. C is the ratio of I1 to V2. So I by V is the admittance, and here it is the ratio of current at the input port to voltage at the output port. So it is the transfer admittance and it is the reverse transfer admittance because it is the ratio of input to output, and the current at the output is 0, so it is the open circuit reverse transfer admittance. Next is B. B is the ratio of V1 by I2, so this is the impedance, and V by I is the impedance, and it is the ratio of voltage at the input to current at the output, so it is the transfer impedance, and it is the reverse transfer impedance. And since the V2 is equal to 0, it is the short circuit reverse transfer impedance. And D is minus I1 by I2, so it is the current gain, and it is the ratio of input to output, so it is the reverse current gain. And since V2 is equal to 0, it is the short circuit reverse current gain. We can say D as also the negative short circuit current ratio. It is the current ratio, so we can also say, name D as the negative. It is negative, so it is the negative short circuit current ratio, and we can name B as negative short circuit transfer impedance, reverse transfer impedance, and A and C we have already mentioned. So that's all for now. Thank you.